What's going on, guys? Welcome back to another video. It's Sheree from ItzSM here today, and today we're going to be doing our second episode in the ML in Minutes course. And today, get excited because we're going to be doing our very first project, the Movie Recommender project. And this project is a combination of multiple different things, such as models, data sets, and so much more, and you're going to learn so much in this jam-packed video. But I will make sure I explain everything very clearly so it's jam-packed yet extensive, and you guys will understand every single bit of it. As always, welcome to ItzSM, where we learn today and lead tomorrow. Creating tomorrow's leaders right here on this channel. Let's go. So first up, our video outline. We're going to be going over a quick introduction, and then a project setup and what we're going to be doing to set ourselves up for this project. And then we're going to actually start working on the project, and finally we're going to end up testing the project, and then the outro, where we'll end the video. The quote of the day: "It is never too late to be what you might have been." So let's say you want to be something really big, but you think you just can't do that anymore. It's never too late. Keep trying, and you will get there. I promise you. Next up, the introduction. This is where your AI ML journey begins, right here in this episode, with the simplest yet most jam-packed project. This is the episode where you will probably decide if AI ML is meant for you. We will explore different topics in machine learning, such as cosine similarity and what models are, and etc. We will understand how the models work and how we can tie them back to human brains. We will understand how to use what we learned today for you to create your own projects later on. Project setup. First, you guys have to go ahead and download VS Code, and then Python, and then set up your extensions inside Visual Studio Code. And I did all three of those things in my last video. So make sure you guys watch that. If you guys wanted to, I also told you guys to study some basic Python terms and ML terms, so you understand what I'm saying. Yes, I will explain them, but not really that much, to be honest, for the simple parts. That's optional. You can probably still understand it without that. So now, let's go ahead and go into our Finder. So I'm going to get out of here. So you're going to go ahead and go inside your Finder. And you're going to go to wherever you want to create it. So I'm going to go inside ShreeM. And you're going to create something. You're going to create a directory that's called... You're going to create a directory. So you're going to go ahead and go into your Finder. And you're going to create a directory called Python AI ML projects. So I want to create it here in ShreeM. So I'm going to go here, and I'm going to go to new folder, and I'm going to rename it Python AI ML projects. And then I'm going to go inside that, and I'm going to create a new file, but we can't do that from Finder, unfortunately. So go ahead and close out your Finder. And you're going to go ahead and open your terminal. Clear some stuff, clear my space up in this terminal. So you're going to go inside your terminal, and you're going to type in cd Python AI ML projects. So it's going to take you into that directory. CD is basically telling your computer to take you into that directory. That's why I highly suggest you create it in your root directory, which in this case is users/ShreeM for me. For you guys, you go to whatever directory you want to create it in. Let's say you're creating it in desktop. Then you would have to cd into desktop and then cd into Python AI ML projects. So you gotta follow the exact file path and cd into one directory at a time until you get into the directory you want. If you don't fully understand what cd does, just go to Google Chrome, type in cd, or type in I want to cd into this directory through this path, and they'll tell you how to. Alright, don't worry about it. If at all you need any help, drop a comment down below and I will help you guys out. So, I promise I reply to comments within the hour that they get most of the time. So just comment down below and I'll get right back to you. Okay, so after you CD into that, as long as you have Visual Studio Code downloaded, you should be able to code dot. Sometimes that doesn't work though. So what you're going to do, sometimes you'll get this error. If you get that error, what you're going to do is you're going to go into Visual Studio Code. You're just going to open a new window, and you're going to go and search, and you're going to do path We're gonna do code. Actually, I'm not sure. Oh, so you're gonna have to this symbol right here, the greater than symbol, and then do code or path. Either one will work. And then you're gonna click this one right here, shell command install code command and path. Click that. It'll say installed in path, and try running the code again, and it'll open it in Visual Studio Code. So there you have it. Now if you take a look at your Visual Studio Code window, just make it full screen, you guys will realize that it now says Python AI ML project. So it opened that directory inside Visual Studio Code, which is exactly what we were going for. Now you're going to click this little new file thing right here, and you're going to make a new file called movie recommender.py. This .py just means Python, and make sure you have the Python extension downloaded. But all three of these, Python debugger, Python, and Pylance, they're all going to help you with creating your Python stuff. And make sure you download Python, otherwise you will not be able to run your code. You guys can also use Replit or any IDE you want. I just like Visual Studio Code, but if Visual Studio Code doesn't work for you or you just don't like it, you can go to any other editor. And if you need help with finding one or need help in general with anything, once again, drop a comment down below and I'll help you out. Also, make sure you like, subscribe, and hit the notification bell so you know when a new video comes out. Alright guys, that's actually my bad. You're not going to name it Pi, you're going to name it IPYNB. So this is going to turn it into a Jupyter notebook, and I'll explain what that is in a bit. Make sure you go to extensions and download the Jupyter extension, Jupyter Notebook and Jupyter Key Maps. Download both of those and they will help you out a lot. They won't work without those, basically. So now you should be able to see this kind of interface right here. First things first, you're going to go to select kernel, Python environments, and choose one of your Python versions. I'm going to choose the newest one I have, which is Python 3.13.5. Basically what a kernel is it's going to let you run your code. Your code has to have an environment to run in, and that's essentially what a kernel is. Because it can't just run in Visual Studio Code, it's got to have a dedicated Python environment to run in, which in this case we'll be using Python 3.13.5. Again, completely up to you what kernel you want to use. You can also use a Jupyter kernel or any other paid kernels out there, but Python is preferable for me. And now you're going to click this code thing right here or up there, and it's going to create a little code area. I'm also going to be adding markdowns in between. The markdown is just for you to add random stuff, like so if you ever come back to this file, you know what is going on in this section of the code. I'm just doing that so you guys know what's going on. You do not have to add the markdowns parts. Just letting you guys know, you do not need to add the markdown. I'm just going to add my own markdown so I can explain to you guys what's going on, and I can also come back to my code and know what's going on. So importing all necessary components of this project. And I can also make this, there. Alright, so that's my code, that's my markdown right there. And you can also add these asterisks, and it'll make it italic. And if you add double asterisks, it makes it bold. So now you have a bold markdown. And now code. This is going to be a code spot, so you can delete this. Go under the markdown and hover, and it'll show you these options. Click code. So now you have an area to run code. So essentially what a notebook is it's code separated into different levels. It's semantically separated. So you have markdown and you have code. So you can either write markdown, you don't have to, but it's mainly used to separate your code into different kernels. So you can test your code at different stages. So I can test just my imports and make sure I have all those all those libraries before I continue into my code. For example, let's say at a restaurant, right? Before they can make the food for you, they've got to be able to get your order, and then once you give me the food before you leave, you got to pay for it. They obviously aren't going to make you order, eat, and pay all at the same time. That's impossible. Also, it's just not safe, and it's going to rush it too much. So what you got to do is they're going to make you order first. They're going to prepare the food and let you eat at your own time. Make sure the food's good. Make sure they prepare it well. And then they're going to make you pay and exit. Same thing with this code. You got to import everything, which is basically, in this case, we'll just use it as an example of getting the person's order. They're going to import it. Import everything they need. They need to make sure that works perfectly so they get the exact order. They get the exact imports that they need. Then, preparing the food. They need to prepare all the necessary things before they get into the actual functional code. They have to do that kernel by kernel, not kernel. They have to do that block by block in the notebook so that they can test each one separately and know where the error is if they get an error. That's why notebooks are so useful. Let's say you put all your code into one of these boxes and you run it and you get an error. Since the error markdown isn't very good in Python, it won't tell you exactly where the error is usually. But if you have these box by box, when you run each box, you'll know there's an error in that spot. So you'll know where the error is. You can fix it just in that spot instead of having to search the entire area for where that error is. That's what a notebook is useful for. If you still don't understand, comment down below and I'll help you out. Okay, so our first thing we're going to do before we do anything is we're going to have to download our data set. And that is going to be called movies.csv. I will have the link down in the description below. So all you have to do is go ahead and copy that. Download that from the description. And worst case, if I forget to put it in the description, just comment down below. I'll add it immediately, but I'm going to remember to put that in the description down below. Okay. Movies.csv is now added inside our project directory right here. A CSV file stands for comma separated values. So it's a bunch of values in rows and columns, like an Excel sheet. So now we're going to load this data set. So loading the data from the CSV file to a pandas data frame. Before we do that though, we're gonna have to, I forgot to do this, we're gonna have to import everything. So insert a code box above the comment and import numpy as np, import pandas as pd, import difflib, import sklearn. I'll go over all this later, by the way. Import, sorry, this should be from sklearn.featureextraction.text, import t fid vectorizer from sklearn.metrics.pairwise, import cosine similarity. Now to run this, you're going to do shift enter. No module named pandas. That's weird. Alright, so if you ever get an error like this, all you're going to want to do is open your terminal, clear that up, and you're going to do pip install pandas. Pip is your Python package manager. Okay, so now that I installed it, it'll work. That's weird. I thought I already had it installed, but it worked. So now it successfully ran all of this, which means I have all of these libraries. If you don't have some of these, like sklearn or difflib, just do pip install and then whatever the library name is, like difflib or sklearn. So what each of these are: numpy is a Python library to work with numbers. Pandas is used for extracting data sets and turning them into data frames, which means you take these values from the CSV file and you turn them into a data set. And a data set is essentially a bunch of values, and I'll show you exactly what it looks like in a bit. Difflib, you'll see what that is later on. Scikit-learn is a library with a bunch of different models, and models are what are used to do the actual machine learning. The models are like the brain of the machine, of our computer. We just imported some things from there. So loading the data. So movies, data, equals pd.read.csv movies.csv. Run this. Successfully ran. Now we're going to add markdown under this, confirming that data set was read properly by the machine. Okay, and now in our code, printing the first 5 rows of the data frame. And we're going to do movies data dot head, and head is essentially going to print the first 5 rows, and if we did dot tail, it'll print the last 5 rows. So if you go above this, you can see this is what a data set looks like. There's index values, which are telling us what point each entry is in. For example, since this movie right here, Avatar, is the first entry, its index value is 0. Since this Disney movie, Pirates of the Caribbean, I think, is second, its index value is 1, and so on and so forth. Now the budget is how much money is spent on it. These are the genres that it falls under, the homepage of it, the ID of it. Don't worry about the ID doesn't matter. Keywords, original language, original title, overview, popularity, runtime, and so much more. Director, and a lot of other things. So it has all of this, all of these values for one specific movie. So each column is a different value, and each row is one movie. So it's all the different values for that movie. So now, what we're going to do is we're going to see how many rows and how many columns are there. So, number of rows and columns in the data frame. And we're going to movies data.shape. So it has 4,803 rows and 24 columns. So 24 different features and 4,803 movies, which is a lot. And selecting the relevant features, event features or recommendation. I did not mean to run that. And we have to do this because we're not going to be using every single feature. Not every feature is relevant to deciding what is a good recommended movie. We only need some features. So selected features will be equal to an array, and each array will have the array is an array of strings. So first, genres, keywords, tagline, cast, and director. These are going to be the main ones that we need. And if you go above here, you can see they have genres, keywords, tagline, somewhere around here, tagline, cast, and director. They have all those values, all those columns, and those are the ones that are going to be most important for recommendation. So we can go ahead and print selected features. There it is, our array. So now we have to do something that's called cleaning up our data set, because sometimes, let's say a movie doesn't have a tagline, right? Let's say this random movie in here that doesn't have a tagline. What it's going to say is it's going to say NA, which stands for null, and our model is going to get tricked by these null values, and it won't work properly. So if we don't fix these null values and get rid of them, the model is going to get tricked, and we won't be able to work properly. Because let's say we're looking for the tagline, right? It's there, but that movie doesn't have a tagline. It's going to think the tagline is named null. And let's say that there's another movie that doesn't have a tagline. It's going to think those are similar because they're both named null, even though the null just means it doesn't have a tagline. So we have to fix that by replacing it with an empty string. And the models never take empty strings into account. They always ignore the empty strings. So that's essentially what we're doing. So we're replacing the null values with null string. If we fill it in with a null string, the model will completely ignore it, and it won't work with it, which is exactly what we want, because we don't want it to get tricked and think they're the same thing. We just want the model to ignore those null values. So for a feature, in selected features, I'll go over this in a bit. Movies data feature equals movies data feature dot fill NA null string. Okay, so what this does, for each feature in selected features, so for each feature, which means for genres, for keywords, for tagline, for cast, for director, for each of these inside movies data, which is our data set, with that value. So we'll check for each of those columns. So it'll run through it one time for genres, one time for keywords, one time for tagline, one time for cast, and one time for director. And it'll replace all the null values with a null string. Okay, so run that. Successfully ran. Now we have to combine all the 5 selected features. Combined features equals movies data sorry, I'm not typing very well today. Genres, I'll explain this again right after, plus space plus movies data keywords. Okay, so this is correct, and then we're going to print the combined features. Okay, so what this does is it takes each of the movies with only those selected features and combines them into one. So let me just look at this real quick, right? So let's print this out. Alright, so in the movie that has an index value of 1, that movie has action, adventure, fantasy, science fiction as its genres, and then has keywords of culture and a bunch of other stuff that we can't see because it's too long, tagline, cast, director. It took all of those features of that first movie and combined it all into one single line. So it took it from a data set to multiple lines of text. Okay, that's basically what it did. It went from rows and columns to multiple different lines of specific features. So the first movie, which has index value of 0, as we saw earlier, I think that's Avatar, it combines the genres, keywords, tagline, cast, and director all into one line. So now we have to create something that's going to be able to take a look at all of these rows and understand what features each row has, so that later on we can compare these features and decide which movies are similar. So converting the text data into feature vectors. And first we're going to initialize that feature vectorizer. So vectorizer equals tfid vectorizer. Okay. So essentially what this does is we need a way for our model to understand the different features of each movie, right? Because when we're comparing them for similarities and seeing which movies are similar so we can recommend them to our user, we need to know what features each movie has so we can compare the similarities, which is what tfid vectorizer does. It's a method from scikit-learn, which is sklearn, that we imported earlier, and it looks at all of these different values in each line, so like action, adventure, fantasy, and it assigns a number based on how often it appears in all of these lines. It assigns a number to each of these values. So fiction will have a specific value, action will have a specific value. Let's say there's tons of action movies, the majority are action movies, then action will have a very high value. And that way, each row of text will have its own feature score, which is all of the scores of each different value added up together. This will make more sense as we continue on. So we're going to initialize that. So we're initializing that vectorizer tfid f vectorizer, which is tfid feature vectorizer. So we're going to look at the features and it's going to give them feature vectors. Again, this will make more sense as we continue on. Feature vectors equals vectorizer.fit transform combined features. I spelled that wrong. Combined features. So essentially what this is doing is it's going to take all of our different rows that we have above here and it's going to give them feature scores. So it's going to give them scores and different numbers and values based on what its different features are. And now we can print feature vectors. And there you go. So you have the different coordinates of each value on the actual data set. You don't have to worry about this. We're only worrying about the values. So that has this value. This is the value for the first movie. That's its feature score. This is the feature score of the next one. And later on, when we use our model to compare all of these, it's going to take a look at what other movies have a similar feature score. What other movies have a score that's very similar to this, and that obviously means it's a very similar movie, and it's going to recommend that movie as one of the movies recommended. So now, the fun part. We're going to actually find out what its similarity score is. And a similarity score is essentially what movies are similar to other movies. So what we're going to do is getting the similarity scores using cosine similarity. That cosine similarity is just the model. It's a model from scikit-learn, sklearn, that's going to help us find out what movies are similar to other movies. So similarity equals cosine similarity of feature vectors. So there you have it. That's going to run successfully. There you go. And print similarity. There you go. I know this looks really weird right now. I itself cannot understand what this means right now. At least I can't understand it very well in a way that I can explain it, but I do know how to work with it, and I'll explain that in a little bit. So now we're going to print similarity dot shape, and whenever you add dot shape, it's just going to be the rows and number of rows and number of columns. So it has an equal number of rows and equal number of columns, which is exactly what we want. Okay, so now they each have their own similarity score. So now we have the similarity over here, which is how similar each movie is to the other movies. So now we can do the actual part where we get the input from the user and actually find their similar movies. So now we're going to do all of this last bit in one box. So get ready to do it all in one box. Movie name equals input of enter your favorite English movie title. And we'll give them spaces. Okay. List of all titles equals movies data title dot to list. Okay. So what this does is we're taking the title column from the movie's data set, and we're converting it to a list. So we're taking all the titles of every movie there, all 4,803 movies, all the titles, and turning them into a list. Find close match equals diff lib dot get close Let me make sure I imported this. Yeah, I did. Okay. difflib.get close matches movie name list of all titles. So this is going to take the movie name that the user inputted, and it's going to find the movie title that is closest in the data set that they typed in. Let's say they typed in Avatar, but they spelled it wrong. They typed in avatars with an S. That won't work because it has to be exact to the letter in the data set. There's an extra S, it won't know what movie the user is talking about. So we use difflib, which is difference library, to find the closest match inside the list of titles to the movie name they typed in. So of course the closest match to avatars would be Avatar without the S. So then that is going to be the title that we're going to be searching the entire data set with. So close match equals find close match index 0. Now we need to index 0 because the way it returns this is going to be a list of the closest matching titles. So we need to get the closest one, so index 0. Index of the movie equals movies data dot title equals close match. Index. Dot values 0. Don't worry about too much about what this does exactly. Basically what it does is it gets the index of the movie that the user typed in. That's basically what it does. Just don't worry about exactly what it does too much. If you really want to know what it does, just comment down below. I'll help you out. Similarity score equals list enumerate similarity index of the movie. So this is going to get the similarity score of the movie that the user typed in. So basically it's going to find the index of that movie, is going to find that inside the list of movies, and it's going to find out what that specific movie's similarity score is. And then sorted similar movies equals sorted similarity score key equals lambda x 1 reverse equals true. So this is going to sort all the movies out by their similarity score related to the similarity score of the movie that the user typed in. So it's going to sort them into an order where the most similar score is on top, least similar is on the bottom, which means most similar movies going to be on top, least similar movies going to be on the bottom. It's just sorting that out. Print movies suggested for you are, and this \n is just adding a new line so that all the movies print under that instead of on the same line. I equals 1, and we're gonna do this. I just stands for index for movie in sorted similar movies. Index equals movie 0. Title from index equals movies data index equals index title dot value 0. If I is less than 30, I'll explain this in a second, guys. Print I okay, so this is kind of a flow of code. So for each movie in sorted similar movies, which is all the movies sorted, for each movie it's gonna get the index of it, which is the first value in this list. So if we go back up to this list, the first value is the index, so we're getting index of 0, which is means the first value. That's going to be equal to the index. Title from index. Based on the index of that movie, it's going to find out what the title is from the data set. If I is less than 30, which basically means we're printing 30 movies, 30 similar movies. If I made this 20, it would print 19, I think, or 20, I'm not sure. We've got to find out though. I think 19 because this is 1. But as long as that's how many it'll print. So we'll make this 30, I guess, for now, or make it, I guess we'll make it 10. Just for testing purposes. You can make whatever number you want. And so it should print 9 or 10 of the recommended movies based on similarity score. It's going to print the I, which starts off with 0, and then when we're done with that, when we're done printing the I and dot, which means like 1 dot, so it's like separating the number from the movie name, and title from index, whatever the movie title is. And then it's going to add 1 to I, so I plus equals 1, which means I is equal to I plus 1. So every time it's incrementing I by 1. So when I gets to 10, less than 10, when I gets to 10, so it's going to print 9 movies. So when I actually gets to 10, it's going to stop. It's going to stop printing, it's going to get out and cut. So it's going to print 9 movies, and I starts off at 1. So let's try this out. So now it's going to ask me for my favorite movie title up here. And let's do Batman. It's not really, I don't really have like one specific favorite, so I'll just do a random movie. Batman. Interesting. Okay, we got an error. List of all titles equals movies data title to list. Oh, sorry. This L is supposed to be lowercase, not capital. That's my bad. Alright, so let me rewrite this one part again so you guys can see what it's supposed to be. It's supposed to be movies data title dot to list without a capital L. Run it again. We'll do Batman again. Similarity score equals list enumerate. Okay, this is supposed to be brackets, not parentheses. The index of the movie should be surrounded in brackets, not in parentheses. Run it again. Batman again. There we go. Movie suggested for you are Batman, Batman Returns, Batman and Robin. You can see it has the number and the dot, as we did here, and then title. So you can see it works pretty well. So that is that, guys. Thank you very much for watching today. Make sure you like, subscribe, comment down below if you need any help with anything. I will get right back to you. Hit that notification bell so you know when a new video comes out. And if you guys like this video, share it with your friends. If you want to see more like this, let me know, and I will definitely keep working on this course. I hope you guys like this video. Make sure to email me at sri.monacoraja@gmail.com if you need help with anything. That email should be on the screen right now. Thank you guys for watching once again, and as always, thank you for watching here at ItzSM, where we learn today and lead tomorrow, creating tomorrow's leaders right on this channel. Thank you for watching, and have a good one, guys.